Well, they're 50 volt. So I think if we applied plus or minus 35 or 40, that should be safe enough. Yeah, onto there. Connecting my ground with my power supply, even if the power supply is grounded over here, really should not cause an issue in as much as like some sort of ground fault. Okay, I mean, the amplifier is running from my isolation transformer anyway. Well, possibly a safer way to do this, in actual fact, would be to power this up with these capacitors fitted without the MOSFETs and have a look at the output coming from the other power supply, the small one. If we measure the voltage coming out of that, and I'm guessing it's probably single rail, it could be dual rail, I could probably power this whole thing up then using 2 bench power supplies and not even have the mains attached to it. We can probably fairly easily figure out what comes out of that small power supply. We have 2 capacitors there, side by side, okay, near to the transformer and near to 2 diodes I can see here. One end of each of those seems to connect together, and then they go to these capacitors. Yeah, you can see that. So the diodes are opposite ways round. Yeah, this is what I would think. So dual supply, I think. One diode, other diode. Okay, that connects to there. Okay, this positive end goes to here, yeah, cathode. Another 2 ends connect to each other. They'll probably read to here because of the winding, but they probably go to a center tap. Yeah, it looks like they go to this winding. There's possibly another winding as well. Let's power this up then and see what's coming out of this supply, which we can measure on these capacitors quite easily. I've put this back together. I've replaced the fuse. Obviously the MOSFETs are not fitted. This is the junction between the 2 capacitors from that low voltage supply. That actually goes to here, so we can use this as a ground point. I'll connect my black meter lead to there. Yeah, connected. So we'll go to volts range. I'll put the current limiting light bulb back in. We can see what that does. And then I want to have a look to see what voltage I have on these capacitors. Okay. We see the light bulb over there. What does this do? Bright then off, so that's fine. But I can actually leave the light bulb in. It's not a problem. Okay. What do I have? Nothing. Nothing. Nothing at all. Okay. So there are more problems with this. Of course, although I've switched it off, there's probably quite a lot of voltage in these big capacitors now. 50 volts. 50 volts. Okay, so we can just discharge those. Yeah, that's discharged, just a couple of volts now. Okay. So what's wrong with our other supply? I'm a little bit surprised at that, to be quite honest, because I can't really see how the fault over there would affect this supply, really. We know there was voltage getting into these 2 capacitors, and I'm pretty confident that's what is powering this. I can't imagine anything else powering that. The fuse I put in, by the way, is a glass fuse, not a ceramic fuse. This is what I happen to have. That's fine while I'm testing this. Well, one of these drains should be the positive end of one of these capacitors. I think it's this one and then this one, and this is hot ground, and if that's the case, that should go to there. So I'll just check this out because it's easier for me to trace from this one side of the board to where I'm looking at. So if we go on, a bit awkward to get at, but the positive end of this capacitor to drain, yeah, so we have connection to there, and then That's probably the hot ground, the end of that one. These 2 points being connected to each other. So we go to there, and this should go, yeah, to the source of that one. Okay, so that's plus HT, about 320 volts. That's hot ground. This must connect to here, I would think. Oh, and it doesn't. That's interesting. I would have thought that these are in series and they're switching one end of the primary between hot ground and plus HT. That's what I would expect, but I don't seem to have that. No connection from there to there. Interesting. It's so awkward to do this on this board, but this is the primary side of the transformer, the big one, and we only have 2 windings. That appears to be a winding, and that appears to be a winding, and they're not connected to each other. So one will be the primary, the other one is probably a kind of auxiliary supply which powers this stuff up. It's possible our oscillator needs this one running before that one running. I'm not really sure why, but hey, possible. Because probably they both come up, at least one comes on before the other. So why am I not seeing a connection from here to here? Unless this is wired completely different than I think it is. No, nothing there. I wouldn't expect that, and nothing here either. Okay. Meter's working. So there's 4 pins here, probably 2 windings. That's a winding. Doesn't connect to that one, and that's a winding. And this is your secondary, which we know is centre tapped. And looks like some sort of auxiliary supply there as well. That's also connected to this. Okay. Maybe a tapping rule on the same winding. Oh, there's another one over there as well. That also connects to here. So possibly one centre tapped winding and then another winding there. But it looks okay. There's no open circuits, I would say there. Without taking that out, I can't say exactly how this is wired up. But it's not like I expected. Okay. Well, this is the junction between the 2 capacitors. So if this is a LLC or a half bridge type of thing, you would expect this point to connect to one end of the primary, and it doesn't go here, it doesn't go here, and it doesn't go there. So I'm going to say that this is not the sort of circuit I thought it was. Happens, yeah. Or there's something seriously wrong. So down here we have what look like 3 high value resistors, 330 and 5 zeros, 3.3 meg, and these are quite possibly feeding into this circuit to start this up at least. That reads 3.3. Same. One end of this, what I would think would go to power coming in. It doesn't. I thought this was some sort of startup for that. Does it go to ground? We know this is hot ground. Yes. So one end of that goes to hot ground. So it could kind of be effectively part of the startup. It's just rather than having this high value resistors, the circuitry and ground, it has the circuitry and then through this to ground. Same thing really. So if this end is hot ground, then this end, let's see, where is that going to? Well, that looks like, yeah, it goes to safety ground. Okay, so that's not a startup type circuit. Okay, thought it might have been. I may have to unsolder this to see if I can figure out how this is connected up, and from that how the power gets into this lot. assuming this lot is driving that transformer, which I think it probably is. I also don't see any connection from here into this circuit, so I've probed around here and I don't see any direct connection. I see some semiconductory type things, but I don't actually see any way that this gets into this lot, and you'd assume that it should do if this is running from there. I'm starting to think now that maybe this supply runs from that one. It's a bit of an unusual design, this thing, I think. I'll try unsoldering this and see if it becomes any clearer. Okay, well, first of all, they've hidden a lot of stuff under here. And we possibly have some damage here, okay. Right. I think that explains why we don't have a connection from here to here. Okay. And then we have all this stuff over here, but this is on the secondary side. So now we can see more of it. We can say that that should connect to here. I'm not sure what this is. It's like the remnants of something. There to there. Okay, then this end is hot ground. So power in, junction of the two. Hot ground. So let's look at this winding. Try to make some sense of this. We have 2 and 2 and 1. So these two connect across there. That reads open. Then we have 2 that connect across here, which are these. That reads like a short, okay. And then the one at the end doesn't go to anywhere, but these don't seem to go anywhere either. Well, there are certainly wires that should go to here. So this pin doesn't read anything to there. Okay. Doesn't read anything to here. Doesn't read anything to here. And does that go to the end one? Well, that looks like there's no winding. That's just like a support. Okay, so there's only 2 windings. This one is intact. Reads, let's see, 0.17 ohm. And this one is 0.3 of an ohm, so it does connect. I had a bad connection on it before. Okay, so that's a winding and that's a winding. Okay, so we have a winding from here to here and we have a winding from here to here. This one is where the source of the high side switching MOSFET connects to the drain of the low side. That's why there was no short across these two capacitors. You remember early on I said if these were both short there would be a short across these, and there wasn't a short across these, but when I took these out they were both short. That's why. I can't quite imagine what that would be. One of these things maybe? What are these things? How do these look? Just say GF on them. Well, they read open circuit. That would suggest there's some sort of capacitor, but it doesn't really make a lot of sense to me. Okay, you guys, what do you think about that? This lot is all on the secondary side, and I suspect, yeah, look, you see these links here? This is what's driving the synchronous rectification. Can you see? This goes into this one, this goes into this one, and no doubt those two go into those. So that's your synchronous rectification drive circuit. The fact this is open here may have something to do with why there's no voltage in here, but I wouldn't have thought so, because that point is just driving the primary. I would have thought whatever drives this is powered from that. And it's also possible that this here is actually powering this, which means that both power supplies are going to come from there. Although that's a strange thing, again, having that driving both. Whatever these are, they connect in series across the divide between the live side and the safety ground side. So they must be capacitors, I would have thought. Probably similar to like the X or Y capacitors you see in switch mode power supplies to ground. Let's take this one out as well and see if anything's hiding under there. Okay, nothing hiding, but it tells us something. So from here goes into one of the windings there, and then the other end of the winding, well, looks like it's a capacitor, and that comes back into this. And then I think you can see there's some tracks here looking through the board which go into this capacitor. So this powers this circuitry, and then there's some more tracks there which go off up here into this lot. Okay, so that's another secondary, comes through into here somewhere, so it powers this, and then it powers these two tracks come into all this lot. So that's also powering the synchronous rectification. Okay, but it doesn't go to these diodes in this circuit. They come from here. Fuse. That's that little fuse that I said wasn't a very high powered rating. So that power rail is powered via this fuse. So all the power on here appears to come from the main supply. Okay, so yeah, that does seem to be driven by the same chip which is driving this, and because it controls the synchronous rectification, this has to be running first. Yeah, that has got to be running first before we get any output from this one, and then this provides power into this lot and also via that fuse into the circuit for this. So that's how it actually works. So my idea of being able to test this was based on how I thought this operated. It does not operate that way, so I can't do that really. Okay guys, it's tomorrow. I was thinking about this one in the night because it didn't make a lot of sense. So I'll show you how this actually connects up. It's not quite how I expected it would be. I thought this was a half bridge LLC type circuit, and it sort of is actually, but not as we know it. So I'm going to draw what I thought it was and then show you what we actually have. So generally speaking, when we have a switch mode power supply with two large electrolytic capacitors like so in series, which is what we do have, okay, this is HT plus, this is hot ground, and these basically are connected to the bridge rectifier, plus minus, and this is your AC coming in. Okay, then with the pair of large capacitors, we see there's an ATX power supply commonly and elsewhere. We have two switching transistors or MOSFETs. Okay, that's what's gone short in this power supply. So in this case they are MOSFETs. Pair of them. This is controlled by that SG3525 via some circuitry. Okay, that's controlling those. And then normally you have the primary of the transformer, the big switch mode transformer, and quite often, in fact generally, there's another inductor in the circuit in one order or another, and there's a capacitor and it goes to there. This is the large kind of orange or brown capacitor you often see in ATX power supplies near to the two big electrolytics, and this is called an LLC. I'll put the C there because it stands for inductor capacitor. And how this works the controller switches these on alternately. We've done this before, yeah, but quick reminder, these switch on alternately. So this end of the transformer primary is switched rapidly between roughly 320 volts. More if we have PFC, this one doesn't have, and 0 volts. Okay, so this is being switched backwards and forwards. That effectively drives AC into the transformer primary, and the other end of the transformer primary via this inductor and this capacitor. Remember, this is high frequency AC, so it will pass through that capacitor. Goes to here. And this point is effectively halfway between HT and ground, about 160 volts. Okay, it's a capacitive divider. There's usually a couple of resistors as well, like so, and they also connect to here, and they are just to make sure the capacitors stay evenly charged and balanced. So we have 160 volts on there, and that's what's happening usually. So this end of the primary effectively has 160 volts on, at least to AC, and this end has been switched between 0 and 320. So the current here flows backwards and forwards rapidly, and then we have our secondary windings and diodes and output capacitors and such like. Okay, usually that's center tapped, something like this. Okay, or sometimes something like this. Jump lots of wires like that. Okay, so that's what I thought we had, and we don't. If we did have this, we'd find, first of all, these are the two MOSFETs, so drain, source, drain, source. They're in series, which is what we've got, and the junction between the two would connect to one end of the primary, and we can find where the other end goes. Okay, and this is important because this is where we've got a blown something on the PCB. This is the junction between the source and drain of the two MOSFETs, high side, low side, and that connects to there. And this has to be, it can't be a capacitor. I'll explain why in a minute. I thought maybe it was a capacitor, but I was thinking about this wrongly. So let's get the meter. This is plus HT, we know it is, we measured it before. This is hot ground, we know it is, we measured it before. So this is the junction, and they should be connected. So I thought, oh, well, this is going to one end of the primary, and that's the other end of the primary. That is not the case. Well, it is, but not how I thought it was. So if this end of the primary is being switched between 320 and ground rapidly, the other end there, I thought, must actually go to the junction between these two capacitors, usually via another capacitor and an inductor. And well, the only other capacitors I really see, that's the mains input filter, so nothing to do with it. And we have two here, which are actually in series. We can see the middle point here is connected to each other. And I'm thinking, okay, well, they're using two capacitors in series instead of one. So what we should find is, from this end of the primary, connecting to there, one end with the other capacitor, for here or here, and we don't. Okay, we don't. Well, there's another pin that's there, and that actually connects to that end of the capacitor. But that point is not the junction of these at all. It's that end, hot ground. Okay, so this point here is connected to hot ground and one end of this capacitor, and that does not match our alleged schematic. Yeah. Something else strange as well, looking at this transformer, those two pins we know connect to each other. That's a winding, that's another winding, but none of them connect to here. Okay, and in fact we don't see any wires going to here. but with this as hot ground. And I thought, is there a wire coming in from the top underneath this that I can't see, and it's open circuit? Because surely something here goes to hot ground, or the junction of those two capacitors, and it doesn't. Yeah. Well, I did a bit of poking around and I figured out how it actually is connected. So I'm going to show you this. So this is a half bridge, but it's not a half bridge LLC. What we have is 320 volts. This is the junction. Goes to one end of the primary here. We know the other end of the primary isn't there, even though this goes to hot ground, because there's nothing connected to there. It is actually here. This is the other end of the primary. Okay, that one, and that doesn't go to the junction of our two capacitors at all. It goes to the junction of these two, the two that were in series, and we know that one there goes to hot ground, and we can measure. We find this end goes to HT plus. Okay, so let me draw what we have. And this is a half bridge. So normally you would have your bridge rectifier, plus minus, AC, AC. Yeah. And then you would have one large capacitor here. Okay. This is your 320 volts. HT plus. Hot ground. Same setup that we have. So two MOSFETs in series, yeah. Again, controlled by the SG3525. Okay. These are driving one end of the coil. Okay, and then we have two other capacitors. These are the smaller ones, connected like that. Okay, half bridge LLC, half bridge. Ours isn't quite that. Ours is like this. Okay, but the operation is the same, and that's how it reads on my meter. I've just shown you. The other end of the primary goes to there. Okay, those two are these blue ones, so 270 nanofarad. And those are the two large electrolytics, which are 200 voltage. Okay, 680 microfarad, 200 volt. So that's what we have, and that, to be honest, would be the same as having the one large capacitor there, because that is just a smoothing capacitor. It's not part of the circuit in the way that these were. Okay, so that's what we have. Clearly then, this doesn't go to here, and in fact you can really see this is where it's blown away, but that's a square end. That never went to there. This went to here by what I can only assume is a wire link. I mean, there's a bit of wire there. Yeah, even that's blown a hole into that bit of it. But that goes to there. I can't imagine a fuse in this position, but then if that goes to there, why put a link in here? Why not just, you know, connect that to that, or this to this? It's the junction. So I still don't really understand what that is, okay, apart from a link. Fuse kind of makes sense, but it's a strange place to put it, but yeah, I'm sure that would work. Okay, so that's the mystery, but that definitely connects to there, basically. Could be a little inductive bead, maybe. What do you guys think? I'm interested to know what you think about that. This pin on this transformer obviously does not connect to anything, and it literally is just support. It just so happens that hot ground is there on that pin. I mean, why, you know? Don't really know, but that's what it is. I could take this rubbery thing off. I honestly don't think I would see anything else. I'm sure that just goes into this plastic piece here. Support, okay? This one will be the auxiliary winding, which powers the SG3525 after the initial startup, which is done from the high voltage. We have an output here, which is this synchronous rectifier thing. This is your main HT plus and minus 40 or 50. It has another output here, which is down here. And that, well, if you follow it, it goes through the fuse and then it goes off up there to these diodes to produce the plus and minus, assumedly 15, but something, whatever it is. Okay, the other power supply, we have two wires which go off in that direction towards that capacitor. Okay, you can see through the board, and we have two more here as well. Okay, and we have two more there. Those ones power this circuit, and this is controlling the synchronous rectifier. This one, okay. The other two, well, one will be a primary winding. Oh, there's another one here. Another one down here. So there'll be a primary winding, and there'll be an auxiliary winding, I would imagine. I think those go off up there somewhere. Yeah, they go into this little bit of circuit here. Okay. Which is on the primary side of the power supply. And this comes down this way. I'm pretty sure these are driving that. It's obvious then this supply needs to be running for the synchronous rectification to work. But that doesn't stop this power supply from running. The main one could be running. Obviously nothing coming through here because these are not being switched on. But this power would work. Yeah, off this secondary. So that power supply, as best I can see, can be running. This one has to be running before all the output is available, but it doesn't switch the power supply on. It just makes the output available. And earlier on, I couldn't figure out how this one starts, but it's looking now like this transformer here from these two chips. We know those are connected to the outputs of that, so it looks like that drives both, and that's strange, but that's the best I can come up with. Okay, guys, so fix it. Well, we need to put the MOSFETs in. I need to order MOSFETs. We need to figure out what that is, and I'm hoping one of you guys can tell me, because I'm still not sure about that. And hopefully then it will run. I don't see any faults in this area, and whatever caused this to blow up doesn't seem to have gone back through the circuitry to that either. Okay, but I don't think we can really go further. I thought we may be able to power all this up and see if the amplifier is working, but I'm thinking now we can't. Okay, I probably would just like to check to see if the MOSFETs under here are short, although if they were, I strongly expect I would see a short across either of those capacitors or the two of them in series. Okay, well, I've got the heatsink off. This looks like it's just a big thermal pad. I thought it was glue, but it's not. Okay, it comes off without damaging anything really. Yeah. Now we see the output MOSFETs. What do they look like? Gate to source. Well, it probably won't tell you very much. That one's different. Is this the same as this one? Yeah, and I bet that's the same as that one, because I have a high side and a low side pair. Okay, so I think that's probably okay. They look the same. Parasitic diode with a negative to the drain. Yep. 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 So they're certainly not short. Ohms range. Let's have a look at these gates again. So we know these two are either high side or low side. They're both the same. That's reading very high, 37 meg. even higher. There's a capacitor charging or something here. Yeah, that's good enough as well. Okay, so they're the same as each other, and then the other two, that was about 15 and not climbing up, in this one 15. Okay, so again they read the same as the other one of the same pair. Remember, there's two amplifiers here, so two high side and two low side, so that looks okay. Certainly no shorts. I don't see anything there that would cause the thing to blow up. Of course, we haven't answered the question, why did it blow up? And that was quite violent. Yeah, that was quite violent. Either I think it was just being driven too hard for too long. These MOSFETs got hot and then one failed and it all went bang. Or the other possibility is one of the speakers, so there'll be a woofer and a horn here, probably the woofer failed. So if the, again, being driven too hard, the coil effectively burnt out but went short, or melted and went short, suddenly that could cause this to blow up. But whatever's gone on hasn't really affected the output devices. Yeah, so I think it's more likely that it was being driven too hard and these just failed catastrophically first before they could fail. You guys down there, what do we stick in there? You guys down there. We know what's wrong with it, or at least what we found is wrong with it, and we know possibly why. So what I'm going to do with this one is speak to the customer. I'm going to ask him either A, bring me the speaker cabinet in with the speakers inside it so I can test them myself, or test the speakers. Because if he has seized or blown speakers, which could have caused this possibly, then obviously he may not want it repairing because the total repair cost may be more than the speaker is worth. So that's where we're going to go with this one. Interesting to know what you guys think about that down there with everything else we've talked about. Okay, so maybe we see it again, maybe we don't. I'll certainly let you know. Just like to say thanks for watching. Hope to see you all soon again on Learning Electronics Repair. Ciao for now, guys.